Take a look at this tube. This is the Salmon Cannon, otherwise known as the whoosh fish transport system. We'll be showing you the Salmon Cannon in action a little later in this video, but basically it's designed to move fish really fast. There are many reasons why you might need to move fish from one stretch of water to another. For example, sometimes hydropower dams are stuck in the middle of the route of migratory fish, such as salmon. Salmon are born in fresh water, but then usually migrate to the ocean. When they're ready to spawn offspring, they travel back to the fresh water where they were born. Imagine being autopiloted towards home and suddenly finding a huge obstacle in your path. Dam construction and habitat destruction have been linked to a decline in salmon populations. River and lake temperatures can also play a part in reducing fish numbers. While ocean temperatures are cold, rivers and lakes often increase in temperature during summer heat waves. Unfortunately, the summer season is when the Pacific salmon come home to spawn. They go from spending most of their adult life in the cool ocean water to facing high temperatures in the rivers they're traveling through. This temperature contrast can be lethal if the river temperatures hit 70 degrees Fahrenheit or 21 degrees centigrade. Excessive or sudden cold temperatures can also affect the mortality of fish populations. Basically, fish aren't keen on significant temperature change. Rivers and lakes can become colder than usual quite quickly if a large nearby dam releases cold water into them. This can result in reduced growth and weight of fish and ultimately cause their death. Water levels can also cause problems for fish survival. If a river or lake contains less water, it also contains less oxygen for the fish to survive on. Less water also means that hazards such as sewage or industrial waste cannot be diluted, and therefore the fish may die from pollution. Another cause of fish mortality is the introduction of invasive species to the habitat. Invasive species are those that cause a negative impact on an ecosystem, and they are usually not native. However, sometimes an ecosystem changes over time to become a more favorable habitat to a native species, which then moves in. For example, the Pacific Northwest used to have cool, fast waters, but they have become warmer, slower, and deeper, allowing the northern minnow pike to flourish. This pike is a fish eater and loves to eat baby salmon on their way back to the ocean. This further reduces the salmon population. The solution to all of these problems is to move the fish, but how is this usually done? There are several ways that people have tried to help fish navigate obstructions, such as dams. Different types of structures known collectively fish passages are designed to get fish past dams. One of these structures is called a fish ladder, which resembles a kind of staircase. The fish have to leap up a series of pools in order to get upstream. Another type of structure is the fish lift. Fish lifts work a bit like elevators. The fish get channeled into a hopper, which is basically a bucket, and then hauled up. The fish are then released into a flume, and they can then continue to swim upstream. However, these methods of moving fish don't actually work very well. A study published in 2013 into the effects of 5 newly installed fish passages near dams in the US found that only a small fraction of targeted fish species was able to complete their migration. These methods appear to be of limited use in preserving and extending fish populations in places where there are no structures to help fish get past obstacles on their route. Some farmers have employed the more basic but labor-intensive method of scooping the fish into buckets, then transporting them upstream to release them. However, live salmon are very slippery creatures to catch and carry, and the experience can be very stressful for the fish. Such a method can also be dangerous for the worker if they're required to lift heavy buckets or crates full of fish or step into the river to try to catch the stranded creatures. To sum up, wherever there are massive hydroelectric dams, there are loads of dead fish or fish that are so stressed by the survival process that they fail to spawn. How can we make this better and improve fish populations, such as salmon? Enter the whoosh salmon cannon, which fires fish from one waterway to another. Hang on, that doesn't sound safer for the fish. Okay, this is the science part. The tube is connected to an accelerator. First of all, the fish are gently pulled into the vacuum chamber of this accelerator. All the air that is coming with the fish is sucked out of the vacuum chamber and connected to an air blower. The momentum of the fish lets them travel through a one-way well, which leads to the pressure chamber of the tube. The key to making the tube work is the principle of pressure differentials. The whoosh tube is slippery and flexible, much like its intended passengers. Once a fish is inside the pressure chamber, the valve closes, and the tube makes a seal around the fish. The air blower is then used to supply pressure. The tube is operated as either a push system, where there is increasing pressure behind the fish, or as a vacuum system, where there is decreasing pressure in front of the fish. This pressure differential moves the fish and propels it down the tube at 22 miles per hour. I mean, that still doesn't sound safe, right? Some of the reasons for using the tube have little to do with the safety of the device. One of the issues with the traditional fish passages is that they have to use or pump water in order to work. The Salmon Canon doesn't require a lot of water, so it's a much better solution for areas where water is a scarcer resource. It's also very flexible. If you have stubborn fish, they can be guided to the tube. But a 2015 study showed that 500 pink salmon entered the tubes voluntarily, which reduces the work of the fish farm. Traditional fish passages also take a lot of time to build, whereas the Canon could be set up within days. But does it hurt the fish to be speeding along like that? Many studies have been carried out to see whether the tube physically causes harm to the fish, their reproductive ability, or migratory skills compared to other methods of fish transportation. A 2014 physiological stress study on Chinook salmon compared using the tube to transporting fish by hand. They found that there were very few differences in the stress responses of the fish. Although the Salmon Canon was the more efficient method, as it is less labor-intensive. In another 2014 study, they found that using the tube resulted in the reduced mortality of Chinook salmon compared to carrying by hand. Additionally, there was no sign that transportation through the tube had any negative effect on fish reproduction. This was measured through concentrations of the female fish plasma phytogenin, which were of similar levels in both fish that had been transported through the tube and fish in a control group, which had not been transported. In a 2015 study of the potential effects of G-force on the fish, given the speed at which they travel through the tube, they found no harmful effects. So basically, the Salmon Canon is efficient, not inherently stressful for the fish, and seems to lead to lower fish mortality. Not bad. Perhaps one of the most significant studies into the effects of the tube is a 2016 migration study, as previous research has found that traditional fish passages actually hinder successful migration. How does the Salmon Canon compare? While they found that there were no differences in immediate survival between sockeye salmon, which used the tube, and those that use a ladder, the scientists did discover that the sockeye using the Salmon Canon migrated much faster to the next two dams upstream. Perhaps they just got used to the speed. While there is more research to be done, this tube contraption looks like it might have a bright future. It has the potential to support worldwide ecosystems, as it's an effective yet low-cost system, which is quick and easy to set up. It can also support locations where other types of fish passage, such as lifts and ladders, cannot be built due to cost or fears over water management. It can help the hydropower industry to minimize the negative effects of dams on waterways and assist fish farmers in maintaining sustainable fisheries. Most excitingly, endangered species of fish can be moved to safer waters where they can hopefully thrive with increased populations at the very least. The Salmon Canon might be the main attraction in an amusement park for fish. They do seem keen to go through the tube. Check it out. So that's the Salmon Canon. What's the most curious animal transportation device you've ever seen? Tell us about it in the comment section down below. If you like this video, subscribe so you won't miss out on our new ones. And if you feel like sharing this with your friends on social media, please do. Bye for now.